Okay, so hi there, everybody. We're now in our next video in Introduction to Statistics. We're now going to enter the world of probability, okay, in this chapter or this module in probability and probability distributions. So again, the content of this video is taken from the handouts created by Dr. Sweet Rose Leonaris. So let's get into it. So let's introduce first probability. So we say, and we all know that probability, plays a large part in our lives. As basic as weather forecasting. It makes you it affects on how you decide something in your daily lives. For instance, for the weather forecaster, say for instance, says that it's going to be 80%, 90% to chance of raining tomorrow. So it will change or alter your decision in either to bring or not bring an umbrella. Okay, so hence probability plays a large part in our lives. Probability terms in our language differs a lot. So we have the word probable, probably. We can have unlikely, likely, most likely, certain, uncertain, and many, many more. Okay, take note that these terms qualitatively show that the degree of each category is different for every individual. So one may say that, it's probable, okay, which will mean different from the other. So for instance, if your friend will ask you, will you go to his party? So you will say probably, and he will say probably. And maybe your probably is equal to 30% and his probably is, maybe 70%. So there is a need to establish a scale of measurement, okay, of uncertainty. Even though probability is a measurement of uncertainty, but there is a need to establish what it means so that it will be of universal meaning for all. So what are some basic examples of statements and probability? So like I said, I have mentioned already, a weather forecaster may predict that there is an 80% chance of rain tomorrow. So which will alter your decision for tomorrow to bring an umbrella or not. A health news reporter may state that a smoker has a much greater chance of getting cancer than a non-smoker. So there is something in which you compare it with. So since a smoker has more greater risk or chance of getting cancer, so um, it would alter your decision. Would you continue to smoke? You know, it 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 ups your chance of getting cancer. So you can have some decision on that. Or a college student may ask an instructor about the chances of passing a course. Okay, so Miss, Sir, what is the chance of me passing the course? So the instructor will give you an answer. So those are daily examples of probability statements. Okay, but take note, there is a need for us to understand first the terminologies before we enter probability proper. Okay, so before we enter probability proper, we must understand the terms, specifically the terms in set theory. Okay, the language of probability is set theory. So you must have some background in set theory. If not, so it's okay. We're going to start with ground zero here. So let's start first with the term experiment. So this is denoted by your italicized E. Actually, this symbol here is your Greek letter XIC. Okay, but we're not going to use that. An italicized E will do, just like this one. So an experiment is any activity that generates data. Okay, and I want to make this clear that an experiment here that I'm referring is not something like you do inside the laboratory. Those are what we call scientific experiments or deterministic experiments. So those are deterministic. Deterministic because even before you did not create the or do the experiment yet, you have a general idea of what will happen in the said experiment. Okay, a very basic example is when you were back in your grade school class, and then you are told by your teacher to recreate a miniature volcanic eruption, and you have some base and acid with you, and then you put that base you create first a, a miniature volcano there, and then on a cardboard, and then you will put some base over here down here, then you pour some vinegar afterwards, and then it will recreate a volcanic eruption, right? Well, not really that dramatic, but it will recreate the dramatic uh, uh, volcanic eruption. Okay, your teacher knew this exactly because it is deterministic. Okay, even before the experiment is done, or even before it has begun, we know already what will happen in the set experiment. So those are what we call deterministic experiments. The experiments we're referring here are not deterministic. These are experiments that are statistical. Okay, statistical experiments are what we call stochastic experiments. Stochastic. Stochastic, which means whatever you do, whatever you alter in the environment that you want to try to recreate, that exact moment, it's not gonna be that possible. Well, it may be if it is all exactly the force and the momentum and everything that you do with the activity. It may be, but it's not a guarantee. Okay, so it's any activity that generates random data. That's stochastic experiment, and that's the experiment that I will be talking about here. So every time I say the word experiment, what I mean or what I will mean is stochastic experiments. Okay, so this experiment has three components: an action, an instrument, and the number of trials or repetitions. Okay, so one or two or three examples of stochastic experiments are like, um, picking a card from a deck of cards, tossing a coin, and throwing a die. So, for instance, I will say I will throw a coin thrice. Throw is the action, coin is the instrument, and the number of trials or repetitions is the thrice. Outcome. An outcome is each possible distinct result of an experiment. So imagine yourself. We will toss a coin once only. So what are the possible outcomes of that? You may get a head, you may get a tail. Okay, so each of these are what we call outcomes. Outcomes. In some books, they may call it a sample point, but it's this of the same meaning. Don't worry. Okay, you may wonder why it's called a sample point or an outcome. Because if you try to collect these outcomes, imagine this experiment again that we have. We only have two possible outcomes, so we can put these outcomes in a set. And this is now actually the collection of all the outcomes in this given experiment that we have. If we have collected everything, all the possible outcomes, we call that a sample space, denoted by your big S. This is a set of all possible outcomes of an experiment. Okay, so that's what we call a sample space. An event, on the other hand, is a subset of a sample space. So it's it is a smaller part. It's actually a part of a sample space. It may be it may have outcomes less than the sample space. It may have outcomes equal to the sample space, but it will not have outcomes more than the sample space. So that's the definition of an event. Okay, a smaller part. So it is a collection of outcomes satisfying a certain condition. Okay, satisfying some condition. So we call that, we denote that by our big letters, except the letter S, because letter S is already taken by our sample space. Okay, and we have types of events. We have first the simple event. So simple means there's only one possible outcome. Compound means there are more than one outcome. Impossible, denoted by this null set here, or empty set. Going back in our set theory, this is our empty set, right? So this is an impossible event. This is an event that will never happen, and hence there are no possible outcomes that can be produced out of there. And a sure event is an event that will really happen, no doubt. It's only by your sample space because it has all the possible outcomes of any experiment. So when you say that it has all the possible outcomes, it's a sure event, and hence it is equal to your sample space because it has all the possible outcomes. Okay, so you may rewind the video if you want to have further clarifications for this. Let's further move to give you an example of these terminologies that we have just talked about. So let's consider an experiment of rolling a six-sided die once. So activity, instrument, trials. If this is the case, if we're going to roll a six-sided die once, we're going to consider a sample space which looks like this. Because if we're going to roll a die once, imagine a die, and we're going to roll this 1. So we have 1 here. For instance, we have 2 here. We have 3 over here. So if we're going to roll this, we have only 6 possible outcomes. So 1, 2, 3, 4, 5, 6. Now we will let or denote A to be one of the sets. Set A to be the event of getting an even number. So since we're going to talk about even numbers, we're going to look at our sample space and check how many even numbers we have. So even numbers are numbers like 2, 4, 6, 8, 10, and so on. So we have 2, 4, and 6 here and no more. So therefore our set A is equal to 2, 4, and 6. Okay, our set A is equal to 2, 4, and 6. Okay, that's our set A. Let's have another example. Event B is getting a multiple of 5. So here, our multiple of 5, you remember multiples of 5 to be 5, 10, 15, 20, and so on. 0 can be a multiple of 5, by the way, but there's no 0 there, and there's no other number, okay, except 5 itself. So hence, event B is only composed of a single element or a single outcome, which is equal to 5. Anyways, I may interchange my words, right? So elements, when I say elements, it means outcome, it means sample point. So don't worry about that. We call event C to be the event of getting a number greater than 6. Um, Notice our sample space, it ends with 6. So there's no possible way of us getting a number greater than 6. So therefore, C is equal to an empty set. Okay, it's an event that will never occur. Okay, and let D to be the event of getting at least 1. Okay, so remember when you say at least 1, it starts with that, and then it will consider all the numbers greater than this number. So when we say at least 1, in symbols, it's greater than or equal to, we start with 1, and we consider all the numbers greater than 1. So hence, what we can see here is that all numbers in the sample space are taken into consideration. Hence, our D is 1, 2, 3, 4, 5, 6, and we can say our D is equal to our S since it has the same equal sample points or outcomes. Okay, so furthermore, I think we can also consider or determine what type of event is event A, what type of event is event B, event C, and D. So event A, since it has more than one outcome, we call that a compound event, right? Event B, since it has a single outcome, we call that a simple event. Event C, since it has no possible outcomes, it's impossible to happen, we call that an impossible event. And event D, since it has all the events, or rather all the outcomes of a sample space, so we call that a sure event, denoted by your big S. Okay, we may also ponder, that's our example. We'll go back to that in a while. If the die was actually rolled, then which of the given events would happen if a 4 came up and a 1 came up? So if a 4 came up, what of these possible events would have happened? Okay, so we can say that a 4 came up when event A and event D happened. Okay, because we can see the outcome 4 in both of those events. So hence we can say that when events A and D happened. How about if a 1 came up? So let's go back in the example. Where can you see a 1? You can only see a 1 here in event D, no more in other events. So hence, a 1 came up if the event D will happen. Okay, so that's it for our first video. I think that's enough. In the next video, we're going to enter to the world of probability. So I think this is the time where I will end or cut the video. So see you in a while.